Welcome to Brain Vision.
For this question, we have a tool in which there is a force that this tool actually supplies. And considering the tool starting at the origin, 0, we want to consider what is the work done by this force that is acting on the tool. Now this force is given as negative alpha x y square j hat. So basically it acts in the j hat direction, which is along the y-axis. Now we are given different paths that the tool can take. So for the first is taking the y equals to x route such that it reaches the point 3, 3. The other path that it can take is moving from x first. This is the second path, moving from x first and then up to 3, 3. So we want to compare what is the total work done on these two different cases, right? So for the first case, we are given that it's moving along x to y. The total work done total work done w is equals to integral of f dot dl, where dl is in the direction that is in the same direction as our f. So our f in this case only works in the j direction, so this must be in dy. And our y changes from 0 to 3, right? And so our f is given. We substitute the expression for f, which is negative alpha x y square dy. But remember that we are traveling along the x equals to y direction. And so what this means is that our x is now equals to y, right? We can substitute x to be equals to y, and therefore our expression for f can be simplified to alpha times y cubed, integrating from y from 0 to 3. Now doing the integration, we should get negative alpha over 4 y to the power 4 from 0 to 3. And we get the work done is negative 50.6 joules. Now the second case, you're going to consider first moving along the x direction, and for this moving along the x direction, the work done is 0, because we know that it is perpendicular to the direction of our force, right? So in any perpendicular direction, it will not do any work. So we can ignore the first part, and we only focus on the second part, right? Second part, when we are increasing our y from 0 to 3, where x is constant. So the work done for the second part, f dy from 0 to 3. But in this case, x is a constant, so we can pull out x. So we just get negative alpha x, and integrate y square inside from 0 to 3 dy. Now our x being a constant is already at 3, so our x is equals to 3. So negative 3 alpha y cubed over 3 from 0 to 3. substituting what is alpha in, which is 2.5, right? 2.5 newtons per meter, we should get work done to be negative 67.5 joules. So we see that these two values are very different, right? So even though their starting and ending points are the same, the total work done by the force is different. So it depends on the path that you take, and therefore our force is a non-conservative force.